Hi everyone, welcome to Microsoft Build 2017. I'm Olivier Bloch. I'm a program manager in the Azure IoT team looking after the Azure IoT SDKs. Well, what we'll talk about just now is actually how, as a developer, you're going to use Azure IoT SDKs to build an IoT solution. So when it comes to building an IoT solution, you first need to understand what exactly we're talking about. So an IoT solution is an aggregation of devices, bits running in the cloud, websites, dashboards, and so forth. Here we have an example of a solution. That one is one of our remote monitoring pre-configured solution. And basically, it uses a service called Azure IoT Hub to ingest data from devices, does analytics on the flight on the data, stores it somewhere, uses a web or an app to visualize all that data, and eventually triggers processes and workflows using logic apps. It's just one of the examples of a data flow for an IoT solution. What we want to focus on is the IoT Hub part of things, where data is ingested from devices, where actually you can control the devices from the cloud. So if you look closer at IoT Hub, it's a platform as a service solution. And what it gives you basically is that notion of a cloud gateway for devices. And what you care about is, as a developer, what are the endpoints? How do I develop against that service? The first thing is obviously the management interface. How do you create an IoT Hub? Once you have an IoT Hub created in your Azure subscription, the next thing to do is to work with the device identity management interface. Basically, IoT Hub allows you to manage devices, assigns IDs to these devices, and deals with authorization so that you have a secure environment where your devices are authenticated, where the device knows who it's talking to. So you have an endpoint on the service side of things, which is to the right of that slide, in order to create new device IDs, manage them, update them. Once you have a device ID created for a specific device, what you can start doing is connect devices to IoT Hub and start sending messages up to the cloud, once again, in a secure and authenticated way. So once the messages are in the Cloud Gateway IoT Hub, what you need to do is actually read them to process them. So the first type of endpoint you'll use is an Event Hub endpoint, where you can actually read the data coming in real time from the devices. Then what you can do from the cloud, on the right side, once again, is use what we call the cloud-to-device endpoint to send a message back to the device. And IoT Hub will take care of sending to the right device you want that message to go to. And at the far left, where the device is, this device will be waiting for a message to come from the cloud through IoT Hub and will be able to answer to that one. There are a couple of other notions. There's one called device twins and the other one device direct methods. The idea of twins is to allow to synchronize a configuration between a device and the cloud, and IoT Hub will manage that twin configuration in the cloud for you. So you're able on one side from the device perspective to receive information for that configuration and to report your actual state. The same way on the back end, in the cloud side of things, what you're able to do is to assign new configuration and properties to a specific device and be notified when the device is reporting its actual state. Device methods is a way to actually call into a device for a specific task to be executed and for an answer to be sent immediately. So these are the various endpoints that you see back and forth from device to cloud. Once you have one device, you can have many devices. You can also attach what we call a gateway, which would be aggregating data coming from several devices that cannot connect directly to the internet and to IoT Hub. Because obviously, if you don't have an IP address, you cannot connect to an Azure service directly. So we have a solution for you if you want to go through a gateway. Last but not least, the Event Hub endpoint to read the telemetry data, all the events that are sent by devices, is not the only thing you can do today. You can actually create new custom endpoints. Today we have event hubs, service bus topic, and service bus queues, and we're working on other ones. And the idea is to allow you through queries to configure how messages will be routed when they arrive from devices into one of these endpoints. So basically, if you want to have all the data coming from a specific device where temperature is above a certain value, and you want to send that to a specific service bus topics for its consumption somewhere else, then you can use routing as part of the IoT Hub interface. So these are all the endpoints you need to understand when you want to develop for IoT Hub, whether on the device side of things, whether on the backend side of things. So the ABC for developing with Azure IoT Hub is the following. You need to create an IoT Hub. I'll tell you exactly how you can do that. You need to create device identities and manage these device identities. You need to use then the client SDKs. There is a set of SDKs for devices and a set of SDKs for service side of things. You will use dev tools, so we have some to help you in your debugging and monitoring processes. And then eventually you can go and start playing with the Azure IoT starter kits. We have a set of hardware, and I'm going to show you one in a minute, which actually allows you to get started super fast. And you can start tinkering with sensors, and you can test your IoT Hub configuration, and then eventually start showing real-time data flowing to the cloud and back and forth. So when it comes to creating the IoT Hub, you have several options. The first one is the Azure portal. So you go to the portal, you search for the Internet of Things category, and then click Create, and you create your IoT Hub into your subscription. You can also use ARM templates. So basically create the configuration in an ARM template, deploy it as part of a more programmatic deployment than the portal. You can also use the command line interfaces. Both the V1, which is based on Node, and the V2, based on Python, allow you to deploy a new Azure IoT Hub and manage that IoT Hub instance. Last but not least, PowerShell, same principle. You can actually run some commandlets that actually will allow you to do that creation and management of an IoT Hub instance. So once you have this online, you will need to start working with tools, right? So command line definitely is one of the ways to deal with the configuration of your IoT Hub and the monitoring of your IoT Hub. So when you're debugging, what you're going to need to do is create a new fake device, for example, identity. Eventually, you're going to want to simulate the data coming from a device, and you will want to monitor the events coming into your IoT Hub. So we're really very much at the, let's say, unit test level, where you want to actually partition what you're debugging. So you want to debug the device on one side, or you want to debug the backend application simulating devices' data. The first tool that I will mention is a command line interface, which is called IoT Hub-Explorer. So if you're a Node developer, npm install -g IoT Hub Explorer, and that tool actually will allow you to do all these operations. If you type IoT Hub-Explorer --help, you'll get all the interface, all the functionalities of that tool. If you're on Windows and you want to have a UI tool, we have one that you can install on your Windows box, and you can use nice click and see, and basically you have the same functionality as in IoT Hub Explorer, but in a Windows graphical app. There's a couple of other command line tools that are very useful when you're doing this kind of development. Because you're connecting over several types of protocol, eventually you're behind a firewall when you're connecting a device. You might want to do the first thing, which is discover the devices on your local network. If you have a Raspberry Pi, which is headset or a headless, or another device with no screen, well, it's hard to determine, hey, what's the IP address of that device that I can SSH into and start working with. So the Device Discovery CLI tool is a very useful tool for discovering the devices that are around you. Another interesting command line tool is the IoT Hub Diagnostics tool. Just mention the fact that you might be behind a firewall, you might be using one or another of the protocols. And so that little tool allows you to clear out issues of connectivity. And eventually it tells you, hey, you'd better use that protocol over WebSockets because it seems you are behind a firewall that is locking down this port and this port. So the IoT Hub Diagnostics tool, same thing, --help, when you invoke it, gives you all the instructions on how to use it. It can save you time trying to put together some software on a device and it doesn't work, I don't know why, my message is not coming up, could be multiple reasons. first check that where you are at, whether it's home, your enterprise, whatnot, you can actually interact with an IoT Hub thanks to that tool. Couple more. We have extensions for Visual Studio Code, if you like that IDE. The first one is an IoT toolkit. This one actually is a pretty cool command line tool that I'm going to use in my demo later on that allows you to do all the operations that the other command line or visual tool can do, but in the context of Visual Studio Code. Very practical and useful. Last but not least, we recently had a team within the Visual Studio group that actually published an Arduino extension for VS Code, and I'm going to use that. And I wanted to mention that one because it works perfectly to integrate into your Azure IoT scenarios development or proof of concept development. So when it comes to developing, well, we don't want you to reinvent the wheel or to just go with like raw protocols for machine-to-machine or devices to connect to IoT Hub. So even though we expose these APIs of the service and document these APIs for the various protocols that are supported, HTTP, AMQP, and MQTT, we do also provide SDKs on the device side of things, on the backend side of things, to make your life easier. And the idea is really to abstract all the complexity of the connectivity, authentication, retry logic, and decompose for you with simple APIs what the configuration of a device twins look like, or simply allow you to attach a callback to answer to a direct method call. So you don't have to go at the protocol level and deal with all of that. You can still if you want, but obviously these open source SDKs are here to help you. We have some for C. We have some for Node, we have some for C# and Python and Java. And all of them are accepting external contributions and are basically developed live in front of your eyes. These actually include both the device side of things and the service side of things. So, but like very often, because we have all these SDKs, all these languages, people are asking me, hey, where do I use what? It's not super clear. So back to this endpoints list here of the IoT Hub. Once again, on the left side of things, we see the devices world. This is the external world, right, non-cloud. On the right side, we have the backend application side of things. The first set of SDK you will use, we call them the device client SDKs. And you have, we have a core one which is developed in C, C99 portable, that today runs on a bunch of platforms, and that you can contribute support for new platforms as well to the SDK. We have a .NET Standard 1.3 version developed in C# that can be used on .NET Core, .NET application, Xamarin application, and so forth. We have a support for Node, and Java 1.7 and above, meaning that Android is supporting using that Java client, device client SDK. And last but not least, we have a Python device client SDK. So this is for what the devices, connecting directly to IoT Hub are concerned. When it comes to gateways, actually we do also have a gateway SDK, and that SDK has a nice architecture. I will not dive too much into that one, but in a nutshell, there's a runtime developed in the portable C that actually is portable to various platforms. And then you have an architecture that orchestrates the communication between modules that you develop using your favorite language, C, C#, JavaScript, or Java. And so the idea is for you to create these entities that are running on a gateway. Maybe these entities are translating from a field bus protocol that is not IP, and you basically expose that device to IoT Hub through the gateway. So this is what the Gateway SDK is about. When it comes to the backend side of things, most of the endpoints are accessible using one of our service SDKs. So the service client SDKs, they're really meant to be run on the backend. And there's a very important point here. When you're working on devices, you have a unique ID and unique credentials for each of the devices. When you're working on the backend, you're working with the secure policies that you set up for the IoT Hub. So you might be using one policy that has access to a certain number of endpoints for several applications in the backend. You don't need to create a new one for each of the clients that will be running in the backend. So this is critical because if you want to have a secure infrastructure, please do not use these keys, the policies for accessing from the backend for devices. We are trying to block that, but at the end of the day, this is kind of the God mode. You don't want that to be in the hands of a device, right? Even though we have very good ways of securing the keys and other credentials on the device. So the service client SDKs you can develop for .NET and UWP with C#. You have support for Node, for Java, for Python, and we also have a C SDK on the service side of things if you're someone who wants to port on esoteric platforms on the back end. So this is for what the cloud to device or the identity management interfaces are concerned. When it comes to the event processing, how to retrieve real-time events from the Event Hub endpoint, you should use one of the Event Hub SDKs. There's one for C, one for C#, which is .NET Standard 1.3 once again, which means it can run on various .NET platforms, including .NET Core, Xamarin, and others. There's a JavaScript SDK for Event Hub and a Java SDK for Event Hub. And then when it comes to the custom endpoints, as I mentioned earlier on, we have Service Bus Topics, Service Bus Queues, Event Hub, and we will have others. You will have to use the SDKs for these various services if you want to grab the information and the data from these SDKs. And last but not least, in terms of the SDKs, and it's basically where they are running and where you can use them. We do have a set of platforms that we do test each time we do updates to the SDKs that are listed here, and we have more actually. The slide is not big enough for them. The idea is to understand that anything that is a device, basically we want to make sure that if it has enough memory, and we're talking about around 64K for very constrained devices, we want to have an option for you to run a device client SDK on it to connect to Azure IoT Hub. And that goes all the way up to bigger machines and maybe servers if you want them to act as devices. But once again, because we want to make your life easier, code is great, and we offer all the instructions for building these SDKs for your platform of choice, but we also offer packages because it's the way you develop, which is, hey, I want that library, let me go into that library or package registry and just get what I need. For .NET and C, we have our device client and service client SDK available on NuGet. We have the device client SDK available in apt-get for C. We have NPM support for both the device client and the service client SDKs. We have Maven, and we have PyPy as well. There is a couple of tiny constrained platforms, such as Arduino or Embed, for which we also offer libs, binary libraries or code libraries into the usually and practically used library or registry for these tools and the IDEs. So let's actually jump into a demo. Let me connect a little tiny device that I have here and send data to IoT Hub and receive commands. What you're going to see right now looks like that. So basically, we have a device that's going to connect securely to Azure IoT Hub. IoT Hub will actually send that data to an Azure function. That function is feeding from the Event Hub endpoint. And what it will do is, based on the message it receives from the device that contains a hashtag or something like that, it will actually pull Twitter for the latest tweet that has that hashtag in there, and will send back that tweet down to the device through Azure IoT Hub. So that's the infrastructure of that demo I'll show. And for that, what I'm going to use is Arduino. And I'm going to run on this tiny device here, which is a MX chip-based Arduino device, and is one of our Azure IoT starter kits. So we have, as I mentioned earlier on, several of these that will allow you to get started fast on your proof of concept development. Here, we're talking about a device which is very cheap and that runs through the Arduino interface or through Visual Studio Code, as I'm going to show you in a second. So let me plug in that little tiny device here. I am in Visual Studio Code, and I have the Arduino extension installed on my machine, on my Visual Studio Code environment, and I also have the Azure IoT Toolkit that I mentioned earlier on. And because this is all development, you can see a nice typo in the middle of it. This is something that we are shipping right now, and you'll get access to starting at build. The examples you can see here are coming from the Arduino IDE interface. Like typically, if I want to see, if you're a Arduino developer, the list of boards that I have installed on my machine, I can, within Visual Studio Code, actually access that list. And here I can see typically the MX chip board that I have here, support package available in the Arduino Boards Manager. Right now, the device is running the little blink application, right? So if you're familiar once again with that, you will see that it's pretty straightforward. We set up the hardware. We are actually writing on one of the outputs to turn the light on and writing on the output to turn the light down. So you've done that thousands of times. So what I'm going to do is actually show you one of the samples that comes with that board library, which is called Azure IoT Hub example. And so this guy here is what it is. This little sample is the one I described in terms of architecture. And not only does it come with the code for the device, it also comes with the code for the function, which is here. And I will describe that code in a second. But it also comes with scripts for deploying the services in the cloud for you, for provisioning the various services you're going to use, and for deploying to the device. So the first thing that I've been doing here was actually to invoke one of the tasks, which was the provision one. So when calling provision, what happens is that the interface in Visual Studio Code will allow you to choose between the various Active Directories that you have. Choose one, look at the subscriptions you have there, pick the one you want to deploy that solution onto, and eventually you can use an existing IoT Hub instance, or it will create a new free instance of IoT Hub. It will also create a resource group for you. It will create a function for you, free edition as well, and then have all of these services hooked up together so that this architecture, where you see the flow of data coming into IoT Hub, then into the function, calling Twitter, back into the function, back into IoT Hub, and to the device, is all taken care of for you. So I invite you to go test it out, run task provision, then you need to run task deploy that actually applies the code of the function that you can edit here if you want to, and then do a build to compile everything and deploy to the device. So what I'm going to do actually is go directly to the build of this solution. And so I'm going to reflash this device using VS Code and Arduino extension. So that's the only command I need to do for now. The thing will run. In the meantime, what I want to show you, I need to reset the thing, that it will actually take over. There you go. So now what I will show you while it's doing that is actually showing the function real quick. So the Azure function is going to run in the cloud. It's very simple. It actually receives a message from the Event Hub endpoint of IoT Hub. And what it does is basically create an instance of a client, which is the service client for Azure IoT Hub. It's using the Node service client here. It opens it, and if it's successful, it looks at the message received. And that message received basically has the name of a device and the hashtag, the topic, which we need to look into for into Twitter. What it will do then is look into Twitter for the latest tweet that uses that hashtag, and then use the IoT Hub service client to send the message back to the device, the tweet text actually down to the device. So this is exactly what the function does here. When I hit deploy into the tasks, it's basically deploy that code into the cloud. So real quick, I want to show you what that resource group looks like in the cloud. I have this IoT Hub that's been created. I have a function that's been created as well. Once again, these two are free editions, free SKUs of that. So if you have a trial subscription for Azure that you don't pay for, then you can also use these services for free to try out Azure IoT Hub and Azure Functions, which is pretty cool. So let me go back to my little project here to see where we're standing. Well, it seems like the sketch has been deployed correctly onto this little device. So what's going to happen now is I'm going to look at the code for the device itself real quick so that you understand what's going on in there. So the device is waiting for a motion. It's waiting on the gyroscope to move in order to do something. We do have here the information that's going to be sent up to IoT Hub, which is a little JSON that has the topic, which is a hashtag to look for in Twitter, and the device ID, which is the device itself, right? If I scroll down here, I have some functions going to help me show a message on the little OLED screen. I can initialize Wi-Fi and basically have one call here for a function which is provided in one of the samples available in the SDKs to send that message. And that little library here that you can see in that sample is also very basic. You prepare a message before sending it. And let me scroll down to this guy. And once you have this message ready, you can actually just send it to that instance of a client, this time the device client SDK. You can send that message up to IoT Hub. So this is the call to the send you see here. And has been invoked into my INO at the moment we shake the device. So let me actually do something cool here. What I'm going to do is I'm going to start with the IoT Toolkit and monitor for checking what messages are coming into the IoT Hub. So let me actually look at the start monitoring IoT Hub messages. And here in the terminal within VS Code, I'm starting monitoring events coming from the device. So let me go to that device here and show you what's going on. So the device is actually displaying here with the init of the app saying, hey, I'm ready. How about you shake? So I'm pressing A, and this is starting the app. And it asks me to shake the device. I'm going to shake the device, strong enough. And what it's going to do is indicate processing. And what's going to happen if I go back to my window here is that there is a message that just came into the terminal. And this is basically showing the message sent by the device with all its properties and queue time and so on that I can read from the cloud in IoT Hub. And because it was super fast, actually, on the device itself, you can see that it already received the message from the function that searched that specific tweet and a specific hashtag and is displaying on the device that I can now scroll down. So you've seen it was like super simple to deploy an application built with one of our device client SDKs, use the service client SDK in a function to have a flow out and in of the IoT Hub. So this is something that was achieved with one of these starter kits that I mentioned earlier on. And so this kit here, you can find it by looking at aka.ms/IoT starter kits. And you'll find other ones, actually. This is not the only one. We have several partners that are certified for IoT that create these bundles that are hardware plus step-by-step tutorials for you to get started. It's pretty straightforward. You imagine like something that actually shows you this kind of flows, as in, hey, just send data to IoT Hub. And it shows you every step-by-step for each of these starter kits on how to achieve that. But then it also goes into scenarios a bit more complex. One here is about using Stream Analytics in order to shove the data into a Power BI dataset to display real-time data from devices in Power BI. We also have another one that shows how from a web app using the Service Client SDKs and the Event Hub SDK, how you can pull the data and control your devices. And we have other ones that eventually you can look into. The machine learning one is pretty funny, leveraging Stream Analytics capability of invoking a cognitive service API directly from the Stream Analytics job is pretty fun. So I'll let you go to the Azure IoT Get Started page in order to get some more information about these starter kits. One thing you can also do if you're interested and want to get certified and train around Azure IoT is actually check out one of our training classes. We have different providers that you can go to and get trained. So that's definitely something you might want to do to learn more, going through MVA and the introduction to Azure IoT, or if you want to go in depth, actually you have 7 days type of training that actually you might want to look into. So now you've seen this demo and all these resources about developing for Azure IoT. And if you want to dive more into that, I invite you to go to the azure.com/IoTDev website or continue your education about IoT Hub going to the ak.ms/IoT training website. Thank you for watching this, and see you soon.